Hey guys, what's up? Today we're going to look at partial fraction decomposition for fractions with repeated factors in the denominator. A repeated factor is a factor with a higher exponent than 1. So in the case that we have here, our x minus 3 squared term is the repeated factor. If instead of x times x minus 3 squared, our denominator was x squared times x minus 3 squared, then both the x squared term and the x minus 3 squared term would be repeated factors. So now that we know what a repeated factor is, how do we split them into partial fractions? Well, we need a partial fraction for each of the exponents of that repeated factor. So in the case that we have here, we need a partial fraction for x minus 3 and another one for x minus 3 squared. If instead of x minus 3 squared, we had x minus 3 cubed in the denominator, then we would need a partial fraction for x minus 3, x minus 3 squared, and x minus 3 cubed. So why do we need a partial fraction for every exponent of the factor? Here's one way of thinking about it. Imagine that you're told 3 unknown factors add up to 7 over 8. So our denominator on the right hand side of this equation is 8. So does that make the denominators on the left hand side also 8? Well, they could be 8 because, for example, 3 over 8 plus 3 over 8 plus 1 over 8 is equal to 7 over 8. But they don't have to be 8. So, for example, a half plus a quarter plus an eighth also equals 7 over 8. So, in other words, the denominators could have been any of the exponents of 2. And in the same way, we have to consider all the exponents of repeated factors when we're dealing with partial fractions. So back to our example, the first step, just like we did with non-repeated factors, is to multiply both sides by the common denominator. So on the left, both the x minus 3 squareds are going to cancel, and on the right hand side, when we expand and simplify, we're going to get a times x minus 3 squared plus b times x minus 3 plus c times x. Also, if you're getting value out of this video, then consider subscribing and hit that bell icon so you never miss a thing. So in order to find a, b and c, we can start plugging in values for x because this equation has to hold for any value of x. The best values for x here are 3 and 0 because in both cases 2 of our 3 constants will be eliminated. So plugging in x equals 0 on the left is going to give us 0 plus 0 minus 18 is equal to a times minus 3 squared plus 0 plus 0, which will leave us with minus 18 equals 9a, and therefore a equals minus 2. So now we're going to do the same thing for x equals 3, and that's going to eliminate a and b, even though we already know what the value of a is. On the left, we're going to get 2 times 3 squared, which is 18 plus 2 times 3, so 18 plus 6 minus 18 is going to leave us with 6 on the left, and on the right we have 3c, and therefore c is equal to 2. So at this point we could plug in any value for x, for example x equals 1, and then solve for b, but just to mix things up, let's equate coefficients. So if we equate the coefficients of x squared, on the left we have a grand total of 2x squared, and on the right, if we were to expand out the brackets, we would have minus 2x squared from the first term and bx squared from the second term. And because we have to have the same number of x squareds on both sides of the equation, that implies that 2 has to equal minus 2 plus b. and therefore our final constant b is equal to 4. And now that we've determined our values for a, b and c, we end up with our 3 partial fractions. Hey guys, I hope you found the video helpful. If you did, make sure to subscribe and let me know in the comments what video you want to see next. For now, take care and I'll see you in the next video.